Okay, so let's do this. This is hypothesis testing, and I'm going to start here in my untitled R. You can actually write a script here. So this is simply hypothesis testing. So what's the goal here? Well, the goal here is first we're going to understand hypothesis testing. So basically, you're going to have a few main points. And the first one is actually quite easy. You have a null hypothesis. Null is nope, none, nothing, no relationship. So anytime you have a null hypothesis, it means no relationship, right? And here I am typing away. And then you might have alternative hypotheses. So we're going to hit the ice cream data set. So here it is, ice cream, right? Very fun thing. Everyone likes ice cream. So we're going to put this up, retrieving the data. You import it. Have to know this. We're going to have a little quiz. What am I doing right? What am I doing wrong? So then you attach it. There you go. Attach. And then you have 3-letter rule. Ice cream comes up. And there you go. You can see the data. All you have to do is go consumption. There it is. Boom. It's there. But I'm going back here. So with the ice cream, we have, let's just say, temperature. We could have two alternative hypotheses. Okay. H01. What is it? Well, that could be temperature, right? Decreases the consumption, right? There it is, consumption. I'll just leave it like that, of ice cream. Or 2, temp increases the consumption of ice cream. Is ice cream one? Well, I'll just leave it like that since that's the data. So increases the consumption of, it's supposed to be of, but that's interesting because that's like if is a command, but we're not going to get into that now. So here you have. So I want to be clear about something. Statistics is about telling a story. Don't get too wrapped up in the math because a lot of people in the social sciences don't like math, so they get scared of statistics. But this package is going to run it. We're going to go over the statistics in a little bit, but the math of it too. But the issue is there is a story to be told. And the story here is, when does consumption fall and when does consumption decrease? So we're going to tell a story. So then you have this hypothesis. The null hypothesis equals no relationship, and the alternative hypothesis is temperature decreases the consumption of ice cream, and the alternative hypothesis number 2, temperature increases the consumption of ice cream. Sorry, I said the first alternative hypothesis is temperature decreases the consumption of ice cream. The second, temperature increases, those are difficult to say, the consumption of ice cream. So we have the data set here. It's not that big, right? But we're going to test it. Now, we did the correlation, but this is different. This is, we're going to use the LM function. And with the LM function, you can call it anything, right? One of my classes, Queen Elizabeth passed away. Love her or hate her, she passed away. So we'll call it Queen E, right? That's what we'll call it. You call it anyways. Now with these buttons, we give it, and we assign, and we're going to create this LM function. So it's called Queen E. Then LM is linear model. And then we're simply going to do in parentheses, the dependent variable comes first. In this case, it's consumption, right? Because we're seeing if temperature causes an increase or decrease in consumption. So consumption is the dependent variable. Temperature is the independent variable. That is the possible cause. So we're just going to go temp. right? You see it right there. It's temp and then comma and then data equals. Now you don't have to do this for this one, but later it's good to get used to doing this. So it is data equals right there. Just get the 3 words. Boom. So this is called our linear model. That's what we're doing. So you have this hypothesis over here, right? We're telling a story. Does temperature have an effect? If it doesn't, we accept the null hypothesis where there's no relationship. However, if there is a relationship, does temperature decrease or does temperature increase consumption? So that's what we're going to do. So now we put a summary. Yay, summary, right? Queen Elizabeth. Boom. There it is. Now let's go up. Bring our, our history. We can put the whole history up there so we see it. That is our model. Now, we're not going to get into the deep math yet. That'll be next week where we start doing the coefficients. But these coefficients that we're plugging in will help us tell a story. So what are we seeing here? Well, what we're seeing are the results. Now, a lot of people get scared. Oh my goodness, this looks so difficult. And it does to the untrained eye, right? You're doing it. But we're going to go hit the p-value first and then go backwards. So this is what we call our p-value, right? Right here, PR, right? The t-value is going to give us our p-value. What does this mean? This means that there is a significant relationship. The p-value is kind of difficult. So anything in the social science, we go by 0.055%. Anything under 0.05 is considered significant. So what you're seeing is temperature has a significant relationship with temperature. So you're essentially finding that 0.05, it's against the null hypothesis. So this is not happening because it's so low when the null hypothesis is true. That means there's no relationship. So you need to have temperature to make the consumption move upward, right? So our data strongly suggests, it doesn't prove, because there are always what we call confounding variables, but it strongly suggests that temperature is causing an increase. How do I know an increase? That is hypothesis number 2. So alternative number 2 right here. How do I know it's an increase? Well, if not, this would be a decrease. So this does not have a negative sign, so it's an increase. So what is this slope? Well, this is telling us for every unit of temperature, this is our independent variable. For every unit of temperature, we're seeing an average positive movement of 0.0031. That might not sound like a lot, but when you look at consumption up here, it's not that much, like 0.38, 0.31, etc. So it's actually saying with every unit of temperature, and the temperature, when you start looking at it, which we can just get right here, is, sorry, that's 41, 56, 63. So it's pretty good to basically have a movement upward of 0.0031 just for every single unit, which, a unit of temperature isn't that much. So that's what you're getting. The standard error is the variability if we do other samples, because remember, statistics, inferential statistics is based on sample population. So this is basically saying you want anything with error, or when we get down here, residual, to be as low as possible. You're really not supposed to want your data to be anything. Just let the data fall as it may. And people who study medicine, that's bad to say I want. It's actually illegal, because if you're doing diabetic medicine, medicine for diabetes, you can't really say I want it to work, because that's actually illegal, because you're going to fudge the data. So it does work. That's called p-hacking, which we'll get into at another time. So basically, though, your model is a better fit if anything with the word error or residual is lower. So these are pretty good. The standard of error is pretty low, saying, and I'm a little incredulous about the standard error. How would you know how other samples pan out? But basically, according to this algorithm, it's saying, you're going to get within this number every time you do another sample. It's the variability of the sample. Remember, variability is the difference. So that's pretty low, 0.00047. And the residual standard error is pretty low, 0.04, but it always depends. It depends on two things. One, what are you measuring? Because as I just showed you, the consumption is by point something. So, that's pretty good standard error and residual standard error. And it also depends on the discipline. So a lot of disciplines demand higher, say, for example, I think it's engineering, I would say, when I talk to them about doing statistics, there's multiple R squared, but that's pretty good for the social sciences. If the multiple R squared, this part here is telling us how much is our model explaining the movement of consumption relative to, obviously, the independent variable temperature. So how much is it moving? And this is telling us how well, right, our independent variable is explaining our dependent variable. So one is perfect, but you can't ever have one because that's the correlation coefficient squared. So the point is that the closer to one, the better your model is doing. The adjusted R squared, we're not going to talk about, but that's when you essentially start adding variables, and it's kind of punishment for that because there is movement towards a better R squared. But the point is, this is how much your model is explaining. This is how much variability in your model that it's not explaining. And let me repeat, not explaining. So lower is better for the model. And 28 degrees of freedom, this is the number of data points, which is important. Some people say the more the better. There's only 30 here because it's 28. So it's 30 minus the independent variable and minus the dependent variable. Those are the data points. So all you have to do is have to look up here, right? And you'll see, make it as big as possible. You have 1, 2, 30. So 30 minus 2, see, I don't even need RStudio to actually calculate that, is 28. So you basically, the degrees of freedom is important because, very low degrees of freedom, it's you only have 5 data points. That's not that good. So we're not going to get into F statistic or anything like that, but this is the P value. And if you do format, right, and you basically are going to copy that, and you can basically get what it is. But I know what it is without, see, the E is the scientific format, and 7 is 7, not zeros, but it would be 0, 0, 0, 0, 0, 0. I'm counting on my fingers. Good, you can't see that. 4. So it's like, 7, 9. So it's basically 7 points after the 7 numbers after the point. So you're basically doing it. You basically know with that E that it is below 0.05. And you also have these 3 stars. And there's a way to format it. If you want to see the exact number, I'm going to say it is scientific. So it is. It's 1, 2, 3, 4, 5, 6, and then 7, 4, and then 7, 9. So that's obviously lower. The scientific part is false, but the E is to the 10th power, so you have it like that. And then you get the stars. That mean it's significant. So I wanted to go over that. It's very, very important, like I did before when we did ggplot, etc. So, I really want to review this stuff so it is in your head. So we're telling a story here. It's basically the idea that we have a hypothesis, right? We want to see if temperature is or is not related to the consumption of ice cream. The null hypothesis, no relationship. The H01, that is basically temperature decrease. You could change them. HO1 is increase and then H2 would decrease, etc. But it doesn't matter. But so we accept. So in this case, we reject this null hypothesis. So we're going to reject the null. Reject the null, right? Oops. See, that's the thing about the writing in R. It'll always pop up like, because there's all these different functions. And then we're going to accept the H0, actually 0, 2. So we're going to accept that, right? I put it because it's a little small, the H0, 2. So basically, we're going to accept that one. That is the alternative hypothesis, and that is ice cream. And now, visually speaking, you could do this visually. So let's say you're in a class. Let's say you hate learning, etc. But we're learning how to do these different graphs. So you go here. I have Plotly in my already. So you basically have that. I believe I did it before. If you don't, all you have to do is install. Remember, anytime we install, just in case you don't, you just go here, not install packages, and then you go Plotly. But I'm not going to do it because I already got it. And then you have to get it out of the library every time you open R. You close it out, you got to get these stuff out of the library. Consider it like the Breakfast Club 1980s. You got to go to the library to get it. So remember, that's ggplot, right? And this will show you visually so it's ice cream data set. I just want to do this other one because it's important to get aesthetics, right? That's the aesthetic. So we get the X. Remember, X is always the independent variable. That in this case is temperature is causing this stuff. And then Y is the dependent variable. So then that's consumption, right? Just put the S and then we see consumption. And then we're going to do geom point. And you're essentially going to understand that geom point is points. So we're going to see points. I'm going to show you, but let's do color. There's only one. Let's do purple. That's a nice color. And then the stat smooth is a line that basically shows you where it's going up and down. So then the method here is what we call LM. That's the linear model because it's all basically continuous variables. And I want to remember, they're obsessed with commas. So let's take a look. I'm going to put a color here. What color? How about blue? I like blue. All right. So, and then we're going to take a look. Here we go. So purple and blue. So we see, even though there's outliers that's points outside, what we're seeing is that it's essentially working. So basically all these points here are the data of consumption related to temperature, and it's going up. And this is called the code. So you have ggplot ice cream with the parentheses, plus, we're doing plus, AES, that's aesthetics, which is the variables you want, X temp, Y cons, that's temperature is causing Y. And remember, cons is here, the Y points down, GM point, color purple, stat smooth method LM. I'll push this over so you can see LM, color blue. Blue is in quotes, just like purple, so it can recognize it. And then that just means GM smooth using what we're using, Y over X. That means X, the Tia tilde. So don't forget that when we do it, we got the Tia tilde because that's temperature causing here consumption. And the data is ice cream. And then we understood the data. This is the independent variable. Will not show the name of the dependent variable, in this case, consumption. This is our slope. This is the practical value. It's saying for every unit of temperature, there is a 0.0031074, don't forget, movement positive of consumption. The standard error is low, which is good. The t-value gives us a p-value, noting that there is movement relative. So the higher the t-value, the better. That shows you the fit for the model. And then we're getting our p-value, which is 0.000, how many 0.0000479? So that's very significant, meaning that it's a relationship. Now the p-value has lost its prestige, but people use it all the time still. I'll get into that later. And then you have basically multiple r squared, which is 0.6. That's pretty good. I mean, that's a pretty strong relationship. Now, why isn't it perfect, like 8 or something like that? Well, because you see these outliers out here, see over here, and you do it. And then we have basically our plot that shows the movement. Now, remember, because it's you just hit the arrow up, and I'm going to put this in. Now, watch the logic here. I'm going to do ggplot, right? ggplot Lee. And now I'm going to get rid of this one. So this is all in there, and then I have to close it with the parentheses. So that's the logic of coding of all these different parentheses. So each parentheses is important, and you put in. So it's really a memory thing. So ggplot, the first one here is the data set. You might not even have a data set, just some points, but we'll talk about that later. But that's the data set in this case. Aesthetics, the independent, dependent variable, GM point, we're doing points opposed to lines. And stat smooth puts this line up here. So, but this is going to make it, ggplotly makes it interactive. So now, as you can see, boom, 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 there it is. And the lines are there. So it's good. Interactive plot. Now, even if you hate it, this is pretty cool to be able to do an interactive plot, right? I mean, it's a beautiful plot. So you definitely want to be able to do that, because if you ever need it for an internship, but just you're doing some kind of graph, we're going to get into other graphs. It's really cool to know. So that is it. And to recap, what we needed to know basically is this hypothesis, the null hypothesis, no relationship, but in this case there is, as you can see. So we accept this, we reject the null and accept the second alternative hypothesis, which it is increasing. Come down here, why? We read the data, the p-value, t-value, standard error, and our little slope here, not the intercept. That's not important right now for linear regression. Then we looked at the multiple r square, which is good, the residual standard error, which is low on 28 degrees of freedom, and then got the real p-value, which is extremely low, which means it is not happening if the null is true, meaning you need the independent variable, because null is when there's no relationship. So the lower the better. Just think, if there's no relationship, okay, the lower the probability of that is better. And that means that there is a relationship when it's very, very low like that, past 0.05 in the probability. The p-value, and then we basically have ggplot ice cream, etc. So I hope you enjoyed this, and please speak to me, email me, leave any comments in community forum. But we're telling a nice story here about how temperature seems to be causing, although we say strongly suggests that there's a causation between temperature and the consumption of ice cream. Take care, everyone.